So what is the golden ratio? The golden ratio is found when you divide a line into two segments and the ratio between the larger segment and the smaller segment is equal to the ratio between the whole length and the larger segment. The golden ratio is an irrational number that is approximately equal to 0.618033398 and so on. It goes on forever. This number is the result of the golden ratio formula, the square root of 5 minus 1 over 2. Since the golden ratio goes on forever, mathematicians often refer to and write it down as the symbol phi. So now, what's a Fibonacci sequence? The Fibonacci sequence is a series of infinite digits in which each number is the sum of the two preceding numbers. This is how it works. Let's start with the numbers 0 and 1. So you take the second number, which is 1 in this case, and the sum, which is 1 again, and you add those two, so it'll be 1 plus 1 equals 2. Then you keep on going. You could also start with 1 plus 0 equals 1 instead. Each sum creates the Fibonacci sequence. So what does the Fibonacci sequence have to do with the golden ratio? If you took any two successive Fibonacci numbers, their ratio would be very close to the golden ratio. For example, if we took the two successive Fibonacci numbers 5 and 8 and divided 5 by 8, it would equal 0.625, which is a result that's close to the golden ratio. But the greater the two Fibonacci numbers, the closer to the golden ratio the ratio is. For example, 233 and 377 are two successive Fibonacci numbers. When 233 is divided by 377 to get the ratio, the result is very close to the golden ratio. Although no two Fibonacci numbers have a ratio that exactly equals the golden ratio. The golden spiral is a spiral that is structured off Fibonacci numbers and the golden ratio. As shown in the video, the golden spiral is structured off boxes, and each box has lengths that are Fibonacci numbers. After the spiral is finished, you can see that the boxes in which the spiral is structured off of have lengths that are Fibonacci numbers. It starts off with two boxes that have lengths of 1, then 2, 3, 5, 8, 13, 21, and 34. As you can tell, they're all Fibonacci numbers. Consequently, if you take any one box's side length and divide it by the square length of its successive box in the sequence, you get a result that is close to the golden ratio. Because the Fibonacci sequence goes on forever, the golden spiral can go on forever too, but since I ran out of paper, I stopped at 34.